Hey folks, so real quick before the video, I just wanted to point out that you need to be extra cautious with certain battery chemistries. Always know the battery chemistry you're working with, what the specific specifications on the cell voltages and how many cells you have in series, or how many S system that you have, 3S, 4S, 8S, 12S, 16S, all determines the specific voltage of your battery, and then the battery or the cell chemistry also determines that. Okay, so figured I'd do a quick video on this DC power supply you can get on Amazon, and well, I mean, the good thing about them is they're very, very cheap as far as power supply goes. This is, I'll have a link for this down in the description, affiliate link, if you want to check them out. They have 30 volts power supplies and 60 volt power supplies. Unfortunately, the maximum amperage you can get is 10 amps at the 30 volt and 5 amps at the 60 volt. So that kind of sucks, but for the price point, what I'm doing is I'm just stacking several of these up, as I'll show you here in just a second. So these aren't super duper precise or very complex power supplies. They're very straightforward. But for most anything, doing the battery systems that I'm doing, they work just fine. So there's the unit. It comes with obviously all the wiring you need, and then just the forward alligator clip harness to go in the front. And I'll talk more about that here in just a second. So essentially, the only thing you need to do is just plug it in and hit the on switch. So you got your voltage course potentiometer here, and then your amperage course potentiometer. And then this is for fine-tuning that, and I'll show you that here in just a second. Amperage and voltage right here. So really, it's just you plug in, you turn it on. As far as the outputs go, it's just positive and negative. Now, the downside about this wire here is, one, because of the contact material, the thinness of the metal, obviously of the plug in the front here, and then the contact material of the alligator clip itself. You do have a lot of voltage loss when operating certain systems. The higher the amperage you need, the more voltage loss you get. At 10 amps, this wire is absolutely inadequate for doing precise voltage inputs to certain systems at higher amperage. At very, very, very low amperage, it's fine, but you have a lot of voltage loss as soon as you need any kind of amperage. And that's just how DC power works. So let's get this set up with the other ones, and I'll show you quickly how I've got these functioning. Okay, so here's what I got set up for multiple supply units. Go ahead and put in the third one here, just like so. And there we are. Not too shabby. So I got two 30 volt 10 amp supplies and one 60 volt 5 amp supply. And so how I have these configured is, so they're all running together. If I need to push higher amperages into a cell to charge it, I can push up to 25 amps up to 30 volts. I do want to get a second 60 volt supply for doing the 48 volt systems, which would be really nice, but right now I'm just working with single cells, so it's not really a problem. So the small contact wires, like these, when it comes to higher amperages, really anything over about 2 amps, you start getting serious voltage loss through these. So these are kind of garbage. So what I got wired in here is silicone 14 gauge wire, and I got these running to XT plugs like that, so that then I can leave these hooked up to the power supply units, and I can plug anything I want into them. So like here, I've got a nice silicone wire, 16 gauge wire with alligator clips for fine-tuning little small cells and different stuff like that, or voltage checking stuff. So, and I can just plug it in, and it's good to go. So I'm gonna wire this this third one, or the center one here that I got now, up the same way, and then if I need to, I can set them all to the exact same voltage, get a split wire, or, you know, like a split harness, and connect them all together and have them all pushing into a cell to combine their amperage together. And it works pretty well. So the way this is set up, I can use alligator clips or hook them directly up to the battery. And see, I got the voltages on these set currently, and that is because I'm testing these LiPo battery cells that have extremely high C rate. And they're 14.8 volts. So real quickly, how you would just kind of go over this, you set your voltage that you want before hooking anything up. So we want 14.8 volts, even though I know this is fully charged, this could be more than 14.8 volts. Then you would hook it up to what you want to hook it up to. Well, first, let's say, set your voltage. Turn your amperage down all the way, both the coarse and fine tuning. And you see the voltage will drop down, but it's set to the correct voltage that I want. So now I can hook up my battery and then tell it how many amps I want to push into it. But since my voltage is set low, let me demonstrate. So my cell right now, or my battery right now, is at 15.2. We'll go ahead and turn the voltage to 15.4, let's say, and you can use the fine tune here to set it. Say 15.45. Let's turn my amperage down and hook my battery in, and then turn my amperage up to whatever desired amperage I want to push into this battery, and it will charge at that amperage up to the voltage that I want. Once it reaches the exact voltage that I want, the amperage will start tapering down until it hits 0. Or, if your battery's not so good, it might just keep pushing a little tiny bit of amperage into it because you got a heater cell or something. And that's where a thermal camera comes really in handy. So that's it. I just want to make a quick video on the power supply units. How to really, for the price anyway, it's way cheaper to just get a whole bunch of these, synchronize them all up to charge them, or use them separately to charge different cells. So I can charge that cell currently that I have with that one supply. I can get this second battery I have. See, that one's a little bit lower. So let's go ahead and turn the voltage up to around the same. Use the fine tuner to put it exactly where I want it. Turn my amperage down here. Plug it in, and then let's say I want to push exactly 1 amp into this battery. So I'll hit the coarse tuner until I get close, and then fine tune it right up to 1 amp exactly. And this really helps for doing real small cells like 18650s and different stuff like that. There we go, perfect. And it will charge this up to that exact voltage. And I can just set that and it'll go. So I'm gonna wire up this third one just like these other two that I have going, and that's my setup currently. So link will be in the description for both of these, the 60 volt and the 30 volt. Like I said, as far as power supplies go, they are fairly cheap, and getting multiple of them to make a much higher amperage still ends up being cheaper than getting a super cheap Chinese high amperage power supply unit that'll do the same thing. Because one of the problems I have is getting a power supply that pushes like 3.65 volts for lithium iron phosphate, but can also do high amperage. So I kind of have to stack a bunch of these up to get the high amperage at that exact voltage for single cell testing. And stay tuned. Coming up next, we're doing a video on the cell load testers. This could be a different thing where I've got these load testers with shunts, and they monitor the exact amp hours and stuff that come out of the batteries. So stay tuned for that. Thanks for watching, and we'll catch you next time. So here's something else that's interesting. I wouldn't really call this a battery chemistry because it's not a battery, but these supercapacitors have, these particular ones, their individual cell rating is a lot like lithium titanate, but these are capacitors, so 100% of their amperage is available instantaneously. Again, they've got their uses. These are some of the most dangerous cells to work with when you're building a supercapacitor system, because you touch those contacts with a wrench or accidentally with a wire or something like that, all of the power in these cells instantaneously will want to flow out the terminals, and it can just explode wires. And another thing with these too is if you overcharge them, they can explode as well, like explode, and they could be hazardous. So keeping very, very close monitors on stuff like this, and just being very, very cautious when you charge systems like this is very important. So stay safe with your power supplies.